I can see we got Gerard and Dennis right now. We might have a few more joining us.
Welcome, guys. We're probably just going to hang around for a little bit before we get started. Make sure we get people joined. People tend to jump on a bit later than the start time.
Yeah, I think they can hear us. So anyways, just to give you guys a brief intro, I'll probably recap this as more people join, just to give it a kind of break period. That way you guys can kind of analyze all the data that's been going through. But I'm Adam Stretch. I am the new Pathfinder for North America. So if you guys have if you need anything, feel free to schedule a call with me or just email me. I'll respond as soon as possible. I'll be over here in Australia until Saturday, and then I head back to the States, and I should be on a better time working with you guys. Let's see what's on the chat here. Okay, cool. They can hear us. So a little background on myself. I just discharged from the U.S. Army after 8.5 years on December 30th. So fresh out of the Army. Spent my entire career as infantry in the 75th Ranger Regiment. And now I'm here as a Pathfinder. Looking forward to working with all you guys. Got a wife, 2 kids. My wife is actually going through one of the With You With Me courses. She's going through the Cybersecurity Analyst course, but she actually might change to data. We've been having that discussion. I myself have gone through the Cybersecurity Analyst course. I'm currently going through the RPA course, and then the next course I intend to complete is the Data Analyst course. And I have an interest in a lot of random things, and on top of that, I feel that it'll be easier to help you guys out where I can if I know what you guys are talking about and what you're going through in the course. So got myself here, got Ben Demain. He's going to be doing the webinar. He's our data guru. And I guess we'll give it, do you want to give it another minute or go ahead and start?
Yeah, well, we'll just we'll ease into it, guys, so that we get some of the people that have registered jumping online. I'll just introduce myself. So I'm Ben Demain, so I'm the lead data analyst here. I spent 11 years in the British and Australian Army in the infantry. So you guys will know that doesn't necessarily translate into any specialist skills. But I spent the last part of my career in data analytics, and I really grew a passion for it. And I guess I would call myself the use case of why veterans are suited to data analytics, and how they can bring their soft skills of problem solving and communication into that field. And so before we get going, I guess, just to explain in context what we do as an organization. So we take veterans, we train them in tech skills, and then we also give them advice and help them help them break into career. As well as that, we provide businesses the opportunity to look at their own staff and then redeploy them rather than looking outside of their organization for tech skills. So we really focus on people not feeling left behind because they don't have the tech skills to meet up with current demands, but people realizing that they can actually break into tech, and for them not to be intimidated by the skills that are actually required. So I'll go ahead and get started. So
before we start, real quick, before we start, we're trying to make this as interactive as possible. So I have the ability to request audio from you. If you don't feel like talking, that's fine. Just deny the request. But if you guys are okay with it, or if everybody here is okay with it, we can go over brief introductions for all of you. We can start with you, Gerard. And if you don't want to, that's fine. Just send in the chat like no intro. I just sent it to you, Gerard. Don't know if it ended up working.
Press it again.
Yeah.
Might not have the microphone set up. Just try Dennis.
Alrighty, Dennis, we'll try try you out. And feel free. We appreciate feedback. We're constantly improving our webinars and our live streams. So if you're just like, hey, it might just be easier for us to use chat, that's fine too. Love the feedback. That helps us improve and make it better for you guys.
Well, we've had like some introductions through the comments as well, guys. So that's great. So we might just continue. But if you want to jump on the audio, just let us know, and we can unmute you on this side.
Yep.
So I'll just get started. So what I'm here to do today is I'm going to introduce you to the field of data analytics. And I'm going to explain what we're offering veterans as a company to break into this field. And I'm also going to highlight why veterans are well suited to data analytics. And then I'll showcase you 2 portions of the course to give you a little taste of what the course is about and what the field is about. So I know you guys have already started jumping on the chat. That's great. If you're just joining us, just tell us a little bit about yourself. Are you a veteran, non-veteran? Why are you interested in data analytics? And how did you hear about us as a company? So why are we here talking about data analytics? You would have heard or constantly hear things about machine learning and artificial intelligence, and how did we get there? So there's 4 major factors that contribute to the environment today. The first one is the amount of data that we've collected. So from the dawn of writing up until 2012, it's estimated that we collected around 5 exabytes of data. And the fact is that now we collect that same amount every day. So how do we collect this data? Well, that was enabled by cheap data storage. To put that in context, a 1 megabyte hard drive in 1967, that would have cost $1 million US. And the comparative price today is 2 cents. And then processing power. Well, there's no point in having all this data if we can't actually process it. And the processing power of our computing devices has increased exponentially. If you look at the Apple iPhone 5, that's 2.7 times more processing power than the fastest supercomputer in 1985. And that's the Apple iPhone 5, right? That's probably sitting at the bottom of one of your drawers, depending on depending on how often you update your phone. And then finally, statistical and programming methods. For many years, the data existed and people didn't know how to actually access it and ask the right questions of it. Statistical and programming methods have advanced so that we can ask very detailed questions of our data. So that's where we are with the environment in general. So what is the field of data analytics? So if you search this online, you'll hear lots of different opinions about it. And that's because it's quite broad. But I've provided a pretty simple definition here, which kind of captures most of it. So data analytics is transforming raw data into insights, which enable decision-making or increase understanding. So what does transforming raw data mean? That means taking data that's unprocessed and turning it into a format that it can be used for analysis. So this involves cleaning the data. It's actually one of the most technical parts of the role, where you have to basically get the data into a place where there's one record per instance and one column per attribute. Sounds complicated, but it can be quite a manual process, but effectively it's an absolutely crucial process. And then turning that into an insight. What is an insight? An insight is something that actually adds value to an organization, and it's something that isn't obvious. So a lot of software will purport to you that you can find an insight with their software in a couple of minutes. Generally speaking, if the average Joe can find an insight, can click and drag something, then that's probably not an insight. It's probably a little too obvious. So these insights need to actually have a purpose. It's not an insight unless it either enables decision-making or increases understanding. So think about what something needs to be in order to enable a decision. It needs to arrive in time, and it needs to arrive in the format that someone can actually do something about it. So you think it involves tailoring to your audience and understanding exactly what they need to make a decision. So you would have heard the 80% solution on time. Data analytics is that 80% solution on time. Data scientists might take far longer to arrive at a way more precise solution. However, the data analyst is there to find quick and ready answers to help people incrementally make decisions. So when you sort of understand that definition, you can start thinking about the person that makes a good data analyst, and you realize it's not just technical skills, it's also about their soft skills. Like, what do you think about that, Alan?
As far as sorry, I was paying attention to the chat. That's
okay.
Getting used to everything. Recap real quick for me.
Yeah, so about data analytics and how it's not just about the technical skills.
Oh, absolutely. Because I mean, if you look at what we do in the military as veterans, like no matter your MOS, your primary concern is analyzing the data and then passing it on to your leaders, or grabbing, if you are a leader yourself, grabbing that data from them. And if you don't have effective data or effective practices for it, everything breaks down. It's definitely a good point.
Absolutely. And the person that fulfills that role needs to actually be able to communicate the results of their analysis to people. It's no good just sitting in a dark room and analyzing data if the actual result of it doesn't make a difference. So then I've got the data analytics process that we teach in the course. And actually, I think that's Rick Canetto on who's joined. Is that right, Rick? So Rick is a recent alumni of the course, and he did very well. He's coming back as a assistant instructor. Rick, just like, if that's you, just jump on, tell people what you thought about the course, and give people a bit of perspective on that. That would be great. So this is our approach to data analytics. So you'll see that typically these three pillars are what a data analyst needs to do their job. So they need the right attributes, the right skills, and the right knowledge and tools to conduct data analytics. And you'll see that a lot of courses approach things from right to left. What they do is they say, if you're good at this tool, then you'll be a good data analyst. But that is problematic. You can be an expert in Power BI, which is a visualization platform, or structured query language, which is a language that interacts with databases. But that doesn't actually mean that you know how to solve a problem. It doesn't actually mean that the skills, that your technical expertise is always applied to the right solution. If the only tool you have is a hammer, then every problem is a nail, right? Okay, so that's what we're talking about. So we say that we start from the left. We're saying that veterans have the right attributes for the job, and that we teach them the skills in the middle. And as they learn those skills, they get targeted proficiency in the tools. But in the end of the day, it's not about the tools. It's about having the right knowledge in the tools to get the job done. So always be, I personally feel, always be wary of someone that is a one tool person. All they want to do is tell you about how to use this tool or that tool, this feature on this tool, or this other feature on that tool. Effectively, what's happened is they're very good at a tool and they don't want to break out of their comfort zone. The most important, the best place you can be is where you can ask what tool is best for this job. And that means that you have to have the right knowledge of a whole range of tools. So let's talk about the course. So the course teaches you to conduct exploratory analysis and then visualize your results and communicate it. And the statistics that we use are fairly basic, but they're really important. They're descriptive statistics. They help us describe what the data is actually telling us. And we use advanced Excel, Power Query, Power BI, and we introduce scripting in Python and R, but it's very on a very basic level. It takes 12 weeks to complete, but the average time is about 16 weeks. It's self-paced, and maybe Rick could say something about that as well. So let's just put this in context. So this is the hierarchy of data science needs. So you know the hierarchy of human needs, food, shelter, water, etc. This is the same thing, but for organizations. The reason that I am showing you this is because you'll see right at the top, there's AI, deep learning, and machine learning. And the point is, you cannot effectively conduct these things unless you have all of the rungs in the pyramid already established. So if you need to conduct machine learning, you need the data to be available, which means that that data must have been first collected, it must have been stored appropriately, and it must be cleaned to be in the right format, because machine learning needs that data to be in a very specific format. It also needs it to be accurate. And the same applies to AI. So effectively, not many problems are actually machine learning or AI problems. 80% of your problems can be solved with less advanced analytics that arrives in a quicker, arrives on time. So the data analyst really sits in the center. The data analyst is in the analyst aggregate ladder, and they have the ability, though, to transform data. And depending on the organization, they might move up the rungs into the top rungs. So I guess it depends. If you're in a very large organization, you're likely to work just in one specific area. But if you're in a small organization, it's likely that you'll move quite far up and down the ladder.
And before we continue from this slide, Ben, as far as we hear the terms a lot, deep learning and machine learning, could you give us a brief description of what that is?
Okay, so the difference between just your normal analytics and machine learning. So analytics and the analytics that we teach effectively descriptive analytics. What we're doing is we're describing what the state of the data currently is. We're reporting on it, and then the steps that we take for it are based on a little bit on our assessment. For example, sales went down 30% last month. So let's look at sales and let's find out which sales went down. And then from that, we can then use our own analysis to find out maybe why sales went down. Are we proving that sales went down because of the things that we identified? No. If we want to look at causation, we need to apply a data science solution. We probably need to spend a lot of time getting our data in the right format, collecting it, and applying machine learning algorithms or potentially AI and deep learning to it. The point is, we don't always have time to get the data in this format. Okay. So machine learning is getting a machine to, in a supervised model, apologies for that, in a supervised model, learning, it learns, you give it the output and you give it the input, and it learns how to get you that output without your supervision. That's effectively machine learning.
It's kind of like almost like ping pong, like it's going back and forth constantly.
It's finding its own route to the solution without your help within specific parameters.
Gotcha.
That's very broadly speaking what it is. So hopefully that puts it in perspective.
Nice.
But yeah, that's a good question. Right. So this is I suspect you'll find the answer to this one, but I wanted you to look at these three characters and have a look and think about who you think would make the perfect data analyst. So Peter on the left, highly creative. John on the right, highly technical. Sandy in the middle, an all-rounder. Let's have a think about that, and I'll come back to that at the end. So now I'm just going to go through some on the course to give you a taste for what data analytics is about and to showcase it in general. How are we going over there? Anyone got any questions up to now?
Yeah, we'll open it up right now. Anyone, any questions about any of the stuff we've covered? Do you need us to go back a slide? We can always do that. We're here for you guys, making sure you guys get the best out of these webinars. I guess in the meantime, Ben, while we wait, we'll give it, just say like 5 minutes. So for someone starting out fresh into data analytics, what's some of your advice getting into the careers of data analytics?
So data analytics, like software development, like in some small cases, cyber, it's about your ability to complete the task. The qualifications around the field are not yet necessarily in place yet. So what it's about is showing someone that you can actually complete the skill. So that means that you need to build up a portfolio of projects that you've done already. So a course is a great start. So you're saying this course has taught me how to conduct data analysis in these environments, and the course that we build has a specific aim of giving you a project that you could actually show at the end and say, this is what I've achieved with data analytics. And some of the projects that students have already produced are actually really impressive. So they study the World Happiness Index, and they look for correlations with happiness against GDP, against other surveyed questions like family support. And so they can, it's objectively interesting to an employer that you can do this. It kind of showcases everything from your ability to use a platform, from your ability to understand a problem. So that's really the biggest thing is giving people more than just some words on paper, an actual project that you can show. So, and the other thing I'd say is that with this, like many tech jobs, people want those unicorns. So they're gonna put in that in that job description, they're gonna put things like potentially, although it is moving away from this, they might very well put things like a degree in mathematics. Okay, but as a data analyst, you do not need a degree in data in mathematics. As a data scientist, yes. Although a master's in statistics would probably cover that. Okay. So you have to just look beyond, get into the mindset of the HR person that's actually writing this resume and understand their opinion of the role is based upon their research, and their research is slightly problematic. Mm-hmm. You need to just explain in your resume and in your cover letter why you're actually suited to the actual core problem that they have as a business, mm-hmm. not all of the bullet points that they put on paper. So don't be intimidated if you don't meet every single one. That's the thing that I think veterans often struggle with. If there's 20 points and they meet 15, they think, right, that's it, I'm not suitable for the job. Mm-hmm. Civilians do not think that way about job interviews. Yeah.
And that's one of the nice things about With You With Me is what we're working on changing is instead of them focusing on the resume, we're bringing in solid data that employers can go off of, such as our potential testing. Like I didn't know I was a kinesthetic learner. I just kind of guessed beforehand. I never knew that, oh man, like I do best with hands-on work. I just kind of guessed at it. When I took the test, it kind of solidified that in my head. I was always kind of in between kinesthetic and verbal, and then boom. And the other great thing about data, I think, and I'm excited to get started on the data analytics course, is the fact that I kind of went through the process backwards. If you have a strong data background, you're going to be more efficient in RPA and pretty much any cybersecurity. It's
transferable to pretty much anything. I saw that question from Gerard. Do you have to have strong math skills? Basically, yes, but the short answer is yes. But let's just think about math skills in general, right? Pretty much any software program relating to data analytics is going to do the maths for you. So let's just appreciate that. If you type a formula into Excel, that formula is producing you the result. So what's important is that you understand what that formula or what that application is actually doing to the data. So it doesn't mean that you need to break apart every formula and have an advanced understanding of it, but you do need to have that type of analytical mindset that can understand the utility of a statistic that you're applying, a statistical method that you're applying, and understand the usefulness of it. Does that make sense? Okay, so now what I'm going to do is...
let's see. Next question is, sorry about this. Slow
what
response.
tool, data analysts have with cloud-based tools, Amazon, Danny, like cloud is an environment. So cloud is like, it's like, I guess that question, if you rephrase it, it's like, what interaction do data analysts have with computer networks? Everything, right? So cloud is the whole package. It's basically it's the place where you do your work. So a lot of interaction, and there's a lot of great tools in Amazon Web Services, Azure, and Google Cloud Platform for data analytics that have the advantage of being able to access resources on demand. So say if you're trying to process something within your network, you need to use the computing power available to you in your actual network. Whereas with cloud, you can access that processing power on demand. From your point of view, though, like these tools are not that intimidating. They're drag and drop. And so really it's just a matter of you learning it. So the point here is learn how to analyze data, and then you can apply it anywhere, right? You can apply it in the cloud. You can apply it on this tool. You can apply it on that tool.
Nice.
Right. So I'm going to continue now with just showcasing the course. So I'm going to talk about visualization. So you may not associate visualization with data analytics, but it's very important. And that's because visualization is more than just making data look pretty. So some people think that visualization is taking a table of data and then making it look fancy. But actually, it's far more than that. What it does is it accesses our spatial memory. And there's actually features called preattentive features that access our spatial memory, and it's a fast track into us understanding data. So let's talk about preattentive features. So that's processed in our spatial memory with no conscious action, and it happens in less than 500 milliseconds. So it's very useful to draw the eye to a specific feature, but also just think about your average, just your line chart. And if you can see that line going upwards, you don't even have to think about realizing that that means that something is growing, right? That's what we're talking about here. So preattentive features, here's what they are. So we've got things like size, color, contrast, groupings. If you think back to your military lessons, this is kind of like why things are seen, how to camouflage yourself. These are the things that work against you, camouflaging yourself. Okay, these are the things that stand out. So I'll give you a demonstration. So if you try to count the number of threes in this 10 by 10 grid, it would take you some time. But if I highlight the threes in red and I change the color of the other numbers to a dark gray, it's far easier to read those threes. And now if I change the other numbers to a blue, it's still easier, but it's definitely not as easy in the previous example. This is an example of preattentive features, the preattentive feature color, and just how much difference it makes to visualization. It's not just about using color, it's about using the right combinations of color, right? So that first one was way more powerful than this one. Okay, and then here's another example, which is size. Like how much easier are these threes to see? And all that's happened is they've been slightly increased in size. So now that we know about preattentive features, should we just load up every visualization that we have with them? Well, no, that would be a mistake, because what they will do is detract from the central point that you're trying to make. So when the brain has too much information to take in, it can result in something called cognitive overload. And that's where the amount of effort to process the information isn't worth the cost of processing that information. So think about if you've been in a presentation and someone brings up a really, really busy slide and everyone just kind of groans and is unhappy about it. That's cognitive overload. It's not that the audience could not process that slide. It's just that the effort required to process that slide is too much for them. Okay, so it's not that. So effectively with preattentive features, the key lesson here is you need to use them sparingly and for a very specific purpose. So let's talk about visualization in general. Why do we use it? And how should we use it? So there's the three main factors: who, what, and how. So when you're building a visualization, think about your audience. Who are they? What's their ability to process information? And what's their appetite for visualization? And then next, think about what does your audience actually need to know? Like, what do you want them to walk away from with your visualization? If you lose track of this, you'll just end up creating things that look nice, but don't actually tell them or don't actually accentuate your point. It might very well be that a simple visualization that doesn't show that doesn't showcase your skills at all is actually what they need to walk away with your point. And then finally, how's the best way to get your message across? So is it one complex visualization that tells the whole story, or is it a series of visualizations? Is it a presentation, or is it a written report, which is backed with visualizations? Okay, let's talk about the two main things to get right in your visualizations. So color and clutter. So we want to use color appropriately and we want to avoid clutter. So why color? Well, color is probably the most powerful preattentive feature. It also taps into psychological associations. For example, red with danger. So you should use color to tie different elements of visualizations together, and I'll show you an example in a minute, and to draw the eye to specific elements of visualization. And when you're using color, avoid those highly saturated, bright colors, or don't avoid them completely, but only use them to draw attention to a specific element. And otherwise, try and use low saturated color palettes. For example, this slide deck is an example of a low saturated color palette. It's easy on the eye, basically. And there are websites like Color Brew, which can show you what these palettes look like. But most applications have options that include low saturated colors. And then clutter. So what's clutter? Clutter is something on your visualization that's actually unnecessary. But generally speaking, it's not also that they're not completely unnecessary. They're just not worth the space. So, for example, you may have an axis title in your visualization, but the axes might be completely obvious. It might very well be, like, for example, months of the year. So it's not necessary for you to put months in that axis title because you can clearly see that it relates to months. Now, therefore it's not unnecessary, but it is an extra element that people have to process when they look at your visualization. So you want to avoid clutter. So let me show you an example of a bad visualization.
Oh, geez. It's rough on the eyes.
So why do you think that this visualization is poor? Can anyone type in some comments?
Yeah, Danny's typing up an answer here. It's pretty interesting. A lot of things you never think about when you're really looking at all the diagrams and things we see on a daily basis. Because, like, for example, I was out in Las Vegas recently, and like they have this billboard, and like everything's all the data from, I think it was like stock market stuff going there, and then it's flashing new stuff the whole time. But I don't think I really ingested any of it. Like I wasn't able to interpret it. I was just like, yeah. That's something else. Pretty interesting.
Yeah. So, I mean, exactly. This is the City of London dashboard. So it's designed for people to log on and find out what's happening in their city. So, exactly. Dennis, it's crowded. Exactly. Asymmetrical. Yeah, that's interesting. I hadn't thought about that. It is too colorful. Right. So effectively, there's too much going on here. And the reason there's too much going on here is because there's too much clutter on this dashboard. Not everything on this dashboard is probably necessary, or if it is necessary, it should be split up into different pages rather than being presented at the same time. Secondly, the use of color is poor, and that's because you've got different color scales here, and they don't tie in together. So why is this bike sharing a different shade of green, yet this visualization a completely different color scale, and at the bottom it goes from red to green? What that does is it just detracts your attention. So your eyes are flicking across to different parts, and it's very difficult for you to actually process this information. So that's an example of bad visualization. Let's look at a good one. So Tableau is one of the leading visualization tools, and they ran a competition, and this particular visualization won that competition. So what this visualization is showing is basically people's percentile rank for age. So it lets you select your age, in this case 34, and tells you how much older, what percentage of the population you're older than. In this case, 45.5%. And then it highlights that on a frequency distribution of people's age. So let's just talk about what's good about this. So let's look at how color is used. So you can see that color is used to tie together the most important elements of this visualization. So you is in blue, your age is in blue, and the big statement of what your percentile rank is also in blue. And then the column that represents your age is in blue, right? So it's easy for someone to make sense of this visualization. And then you can also see with color, you've got, it's a very low saturated color palette, which just means it's easy on the eye, and you can easily distinguish those that are younger and those that are older than you. And then next, think about this graph and look at it and consider if there's anything on it that isn't necessary. And you'll realize that that there isn't. Everything is really important. Everything is well thought out. So the overall impression of this visualization is that it 100% leaves you walking away with the whole point of it. So you walk away understanding how much older you are than most Americans, right? And that's effectively what we're talking about here. So when we talk about data analysis, what happens is that people conduct great analysis of data, and then they fail to communicate that in a way that actually gets the point of their analysis across, which means that nothing actually comes from that analysis. And that's why visualization is so important. And that's why visualization has to be done by the same people that can also analyze the data, because they're the ones that actually understand the problem in enough depth. So here's a couple of ones to avoid. So generally speaking, you should avoid pie charts, and you should definitely avoid 3D charts. And effectively, that's because it distorts your ability to understand proportions when you're looking at things. So what's a pie chart's purpose? It's to show you the proportion of elements in relation to the whole, right? Well, how can you tell that with this 3D chart when it's actually at a different angle, so you can't actually tell what the different segments are. So never 3D. But pie charts in general are a bit difficult for us to process because the angles, we don't process angles that well. But if you look at the difference on the right, this is the same information of the breakdown of these products, and it's just far easier to understand.
I can't think of how many con ops I've sat through in the military, and like you can tell, the officers that are good at presenting and like, giving us those good graphs and everything to really get the concept of the operation down. And then I think most of us have probably also seen the bad ones where it's just an eyesore and you're like, I'm just going to kind of sit through this. And,
definitely. And let's be honest. People are pretty used to receiving such poor stuff that they don't actually know what they don't actually know what they could be. They don't know what the possibilities are, and it's something that people don't put enough effort into, but it really has a lot of impact.
Nice.
So next, let's talk about statistics, specifically the way that people use them misleadingly. The reason why this is important is because it gives data analytics or the results of data analytics a little bit of a bad rap. People lose faith when they hear the media or they hear people misrepresenting statistics. So that's kind of the main reason. So we want to stop you from misusing statistics, but we also want to enable you to quickly understand where something is being misrepresented and identify it. So let's go through the first one. So here's an example, or this is actually the US GDP growth from 2016 to 2018. And President Trump took office in 2017. And let's just say, theoretically, that the Republicans are making a big deal about the difference in GDP growth between 17 and 18, right? Trump is doing well in increasing GDP growth. Can anyone see what's wrong with this visualization?
We'll give you guys a second to answer that. Interesting. These things, you never really, at least myself, never really think about. I see a graph, I see the numbers, and I'm just like, okay, it's okay. I'm interested to see what we got here. Looks like we got Dennis and Danny. Let's see. Yeah,
there you go. So that's actually correct. So this axis does not start at 0. What that means is it gives a very distorted view of how what the proportions of these visualizations. And it correlation equals causation. So you're right, Danny. It does imply that correlation equals causation in the sense that it implies that President Trump taking office has something to do with GDP growth. But the point I was trying to make here, the main one, is that the axis isn't set to 0. So if you set the axis to 0, this is actually what it looks like. So it has increased, but the proportions are far different. So this is actually something that the media has been caught out for in the past. What you can do is just ask yourself, is this graph in proportion? And if you're presenting a graph with an axis not set to 0, and there are reasons for you to do so, just be very clear that you are doing that so that people don't get a disproportionate understanding of what's happening. So that's the first one. The second one is kind of related to this. So if you were to see this graph, you might ask yourself, why am I only being presented the years from 2016 to 2018? What happened in previous years? And that's the second point, which is presenting data or statistics out of context. So here's the context. So here's GDP growth that takes the whole of President Obama's 9-year term. And then now that you see this, you can see that actually between 2013 and 15, there was a very similar pattern. And there almost looks to be a trend in terms of growth. And it kind of puts the previous graph in context and helps you understand what's actually happening here. So this is really important. It's a point to say, if you do, your finding that you present might very well be a small part of the puzzle, but you must also explain how you arrived at it and the process that you got to get there, so that you don't mislead the audience by presenting things out of context. The next one, data not normalized. So by normalized, we mean bring data into common measurements so that it can be compared. So let's look at Company X. Company X has had 350 resignations in financial year 16-17 from males and 200 resignations from females in financial year 16-17. Now, would they be mistaken to conclude from this that their male retention is worse than their female retention? So would they be mistaken, and why would they be mistaken?
I'll give you a second to answer that. It's interesting, like we see all these graphs and everything all the time. We live in this new age of information, and it's nice to actually have that understanding of it now, so that you just don't believe everything you see. And not only do you not believe everything you see, but now you know how to analyze it properly and teach other people. So that's good.
That's absolutely, it's absolutely it. It's to restore your faith in, it restores your faith in things, because you find then that it's not that you no longer trust anything. It's what you do is you know how to process it properly. You know what conclusions to make of it. You know how to interpret it. Effectively, we're talking about basic data literacy. You're able to read the data. You're able to make the right conclusions of it. And if we all were able to do that, we would have far better conversations in general.
I feel like there'd be a lot less Facebook arguments.
Yeah, absolutely. What's the next one?
Let's see.
What's we got?
Okay. So they would be mistaken
absolutely.
Because it does not give the proportion of men to women in its total workforce. For example, in the U.S. Army,
correct,
where the majority of the force is men, one may expect to see. Okay.
That's exactly it there. Yeah, good work. So what we need to see how many total males and females there are at Company X. Then we can work out the percentage of males and females that have resigned. And when we were to plot this, we can see that 35% of females left versus 26% of males. So there's actually a female retention problem in this company. So that's the importance of normalization. This is it's quite a simple example, right? Which is getting the percentage of total. But there's a whole number of different ways to normalize. But if you're comparing two things, you need to compare apples and apples. Okay, and that's what normalization is about. The next thing is percentage difference versus percentage points. So we're back onto our analogy here about percentage GDP growth. And theoretically, the Republicans are saying GDP growth increased 20% between 2017 and 2018. That's great. That's correct. It has increased by 20% because the increase was 0.5%. And 0.5% is 20% of 2.4%. Are you following me with this? So It's correct. It has increased 20%. When you talk about percentage increases, though, it tends to make things sound a lot more significant than potentially they actually are. So let's look at what the Democrats say. So the Democrats are saying that GDP growth increased by 0.5%. They are also correct because they're talking about percentage points. It's increased from 2.4 to 2.9%, which is 0.5%. It has increased by 0.5 percentage point. This is the difference between percentage increase or decrease and percentage points increase or decrease. So it's just so that you realize when someone says that the rates of something have increased by 200%, what they could be talking about is a difference between 2% and 4%. Or they could be talking about there being, let's say that a company saying that the rates of disciplinary cases have increased 200%. They could have had 2 last year and 4 this year. Okay, that is 200% of an increase. So it's about putting things in context when it comes to percentages.
Interesting.
Number 6, you would have heard this one. Denny, you mentioned it earlier. Correlation is not causation. So what's correlation? Correlation is understanding how two variables are related to one another. For example, height is correlated with weight. Generally speaking, the taller that you are, the more that you weigh. That's useful information to know. You can determine from that if someone is tall, they also weigh more. But it's very different to saying that the reason that someone weighs more is because they are taller, or the reason that someone's taller is because they weigh more. That's causation. That's a completely different example. So you would have heard this idea of correlation not being causation, but people often use this in the wrong context. What they're trying to do is say that correlation isn't useful because it doesn't imply causation. My point is that correlation is still very useful if you apply it correctly. It still tells you, can tell you a lot about two variables if you use it properly. However, it's about how you present that data. For example, you might find that sales are correlated with a particular marketing campaign. Now, you would just say that that these two things are related. You wouldn't say that this has caused these to be correlated unless you had the data. All right, so coming to the end here, let's tell you a bit about our company. So what we do is we provide veterans training to break into careers, but we're also focused on, like I said earlier, the civilian population. We're helping companies use software to find some of their unappreciated workforce and then retrain them into tech skills so that they can be redeployed. So think of your classic commercial company. What they're doing is when technology increases, they're unfortunately firing some of their low-skilled staff, and then they're looking external for their tech staff. And that's a really expensive process for them. They have to pay a whole deal of fees, and it's expensive for them to actually hire the right people in cyber automation and tech into their organization, whilst also having to deal with the repercussions of firing people. What we're saying is there are people in your own organization that you can redeploy if we can help you find them and we can help you train them. So that's what we do externally, and the way that we're able to do this is because we've learned how to do this for veterans already. We've learned how to take veterans, a somewhat unappreciated workforce, and then redeploy them into tech. And that's what we're trying to do for the wider audience here.
And it's interesting that employers don't recognize that yet, because I know for the U.S. military, I think most militaries have this where you can reclass. And if you look at, we'll just say cyber, look at when they were standing up U.S. Cyber Command and looking for cyber, you would see a lot of emails about them being like, hey, we would love to get new people in there, but we already have soldiers who have been through basic training and done all of this stuff, and they know how the process works. So it'll probably be easier to get them into it. And they understand that we're able to transition like that, because I was infantry, but then you have those nice additional duties that you get thrown into. So veterans are very flexible. And I think we're doing a good job. We still have a ways to go in getting the employers in that mindset, because as a business person, I feel like they don't understand how the military is still functioning. And that is one key point of why it is.
Yeah, that's absolutely. So we've come to the end now, and I wanted to show you, come back to this question here. Did anyone have any opinions on who would make the best data analyst of these three?
We'll give you guys a second to look through that, make an accurate decision. It's very, very interesting working with the employers. One of the things I appreciate about the platform is before I even choose a career pathway, I get that potential testing, and it's not gauging me on my resume. It's showing me how I'm learning. Even if I never used anything else from With You With Me, I would be able to keep that testing for the rest of my life and be like, okay, I know how to teach myself effectively. So if I do want to transition careers or anything like that, I know how to do it most effectively. And that's where the data analyst course comes into play too, because even if you didn't get the job title data analyst, it's effective in any career field, and it just improves you in the long run and puts you ahead of the game. because it's basic things you do all the time anyway.
Absolutely. Like, it's hard to think of a role that, apart from perhaps skilled labor, where data analytics would not be useful to you. So yeah, coming on to this, so absolutely, Sandy, okay, what we're not doing though is talking about why John or Peter is not suited to data analytics. What we're saying is that industry looks at the data analysts and the data scientists as Johns. They think that these people are very technical, and that has to come with a cost when it comes to personal skills. What we're saying is that that Sandy and even to some extent Peters are actually really good at this because they actually help solve the core problem. There's plenty of space for Johns. There's plenty of space for Peters to some extent. But what veterans generally bring to the party is a flexibility due to their really interesting and demanding service, with their ability to pivot, learn new things, and actually solve problems. And that's kind of the big value that we think veterans can offer to this field. So yeah, we're pretty finished up here. Thank you for your interaction. I hope to see some of you on the course that's starting on the 31st of Jan. If you haven't, sign up to our platform and then go through the testing and speak to the Pathfinders. You'll probably speak to Adam actually,
Yep.
and jump on the course. If data analytics isn't your thing, we've got robotics, process automation, and cyber as well. So thanks very much for having you on. I'll wait for some questions now as well.
Yeah, absolutely. And like as I was saying, I'm really excited, and this isn't me just like BSing you guys. Like, I'm actually really interested in data analytics because, like I said, like no matter what your job is, like that's only going to make you a more effective employee. And then doing a career in data analytics, you can actually help mitigate all of that disinformation that's put out there, that skewed information. While it may be accurate, it can be taken out of context. And when employers see that in you, like they're going to be, no matter what job you have, they're like, wow, this guy knows how to analyze. He'd be a good leader. He can train our staff. Or like you might get promoted faster, or you might be like the technical expert on it, and then move forward more with data analytics.
Some people asking for links and stuff. I think Javier will jump. Oh, okay. Recording of the webinar. Yes, we can do that.
Let me go check so I can give you guys an answer right now of where you will be able to find the webinar.
Yeah, absolutely. Cool.
And then I guess in the meantime,
I'll just have a look at some of this interaction.
Your experience, Ben, with how data analytics has helped you out in your career?
Absolutely. Right. Actually, there is something else I wanted to show you. So let me just demonstrate to you a product that students learn how to build near the end of the course. So what this is a dashboard. A dashboard is a visual tool that enables people to explore crime in Boston. This is real crime data, and people are able to select districts in Boston and see the actual incidents of crime. And then they can select specific crime types. And the most important thing is they can see the crime per hour, the percentage of crime that occurs per hour against the percentage of overall crime that occurs per hour. So if you're potentially in the Boston police force, you would say that larceny in District A1 is actually occurring on percentage more during these hours than overall crime. So there's something specific about this crime. So this is an example of normalization. You're normalizing the crime per hour by looking at it as a percentage of total. And that enables you to take actually draw some far more specific conclusions about it. Let me just show you another one here. Let's look at motor vehicle accidents. So motor vehicle accidents, right, are occurring at 4 o'clock. They're occurring at a higher rate than overall crimes in District A1. And what about overall? In overall, again, between 4 and 5, that makes sense, rush hour traffic, right? Mm-hmm. Actually, if you look at the visualization, you can see that they occur along some routes, right? You can see the linear pattern. And if you wanted to, you could also select the crime first and then look at the data on the left side as well. So this is an example of what students build during the course, and you can see the value of interacting with data like this. Awesome. And this is really what I guess I'm talking about. Are you proving that motor vehicles are correlated to time? You're not proving it, but you are seeing that the incidents are different to normal. And that might lead you to make some decisions about potentially things like traffic lights or really the possibilities are pretty endless. So yeah, hopefully that's useful.
Yeah, I mean, you could even add that in if you're trying to figure out what your operating hours are, like who you need on staff at certain times of day.
Absolutely.
Super effective. So it increases the overall safety. And it's because you're able to accurately produce data, analyze it, and then hand it off to whoever is managing the shift work or whatever.
That's it.
Yeah.
The beauty of this type of tool is that your shift manager can get on there and actually explore the data themselves. So you're not telling them the answer because people are, let's be honest, people are pretty distrustworthy of that. Yeah. You're letting them see it for themselves and apply the right filters that they think are actually relevant. It's not about being an expert that tells people exactly what to do. It's about presenting decision makers with all of the information and letting them use their experience to actually make the right decision.
Or if you're a decision maker yourself, you'll know if somebody's trying to BS you with some skewed statistics and say, wait, hold on. And you know the exact questions to ask them. Yeah. That's pretty cool.
Definitely. Okay, I think that's it.
Before we continue, what is the job market looking like in data analytics or really any of our courses?
Right. So I can relate to you the job market data for Australia. And that's to say, at the moment, if we compare pathways of what we're offering, RPA is around 350 jobs posted in the last 12 months. Cyber has around 3,000 entry-level jobs. But the data analyst is around 11,000. So there's a far greater demand in general for data analysts, but you must sort of be wary of the fact that data analyst captures a big bracket of people. But that's to say that if you think about it logically, most organizations will have the need for analytics capability. It's pretty crucial. Whereas with cyber, it's slightly more niche, and RPA is growing. So yeah, there are definitely opportunities in Australia. The US, I would infer is a similar situation.
That's actually a good point. If you guys want, like now that you guys know how to accurately, even I know how to accurately look at data a little bit better. If you're interested in what the U.S. job market's looking like, go research the data that is currently out there, and then try and find comparisons of, say, like, okay, they're saying, like, I think Burning Glass did a study for cybersecurity. They're projecting 2 million jobs unfilled across the world, I believe, by 2021. But now I can sit down and look at that information. I definitely encourage you guys to go do that, because I'm going to go do that myself, look at what the job market looks like for data analytics careers.
Yeah, you're very lucky to have Adam on your side. Actually, he's very keen to get amongst all the different pathways and really understand it from your point of view, guys. So we'll wrap it up there. Thanks very much for joining us. We run these periodically, actually about every 4 weeks, but we'll soon be starting to stream content around data analytics on a weekly basis. So the first one of those is happening in the first week of February. You'll find details on our website.
Nice. And if you guys want to reach me, Adam Stretch at withyouwithme.com. And I'll be happy to answer any questions, get you along your pathway if you're not signed up yet. But yeah, any issues, feel free to hit me up. I'll be back in the States next week, but you can still hit me up while I'm over here. And before we continue, I suppose, what is the start date of the next data analytics course? The
start date is the 31st. It starts on the 31st, and we will, so sign up to our platform, and the rest of the details will come from there. Great.
And I'll produce to you guys any changes, anything like that. Thanks, guys.
Great. Thank you.